Good day and welcome back to another episode of Whiteboard series. Today we'll be looking at the important concepts of electrical systems. Alright, just before I start, I just want to make a disclaimer that this video is really to summarize the most important concepts for electrical system. You would still need to look through your notes as well as your topical practice in order to have a more holistic and comprehensive understanding of the whole chapter. Alright, with that, let's move on. Alright, so the first thing you need to understand is, very importantly, what is a system? I think that's one of the most fundamental things that we need to know. So a system basically is made out of several parts working together. Alright? Now, some example could be your human systems, which I'm sure you are pretty familiar. So, for example, in your respiratory system, you have the different organs coming together to work in order to support the function of the respiratory system, which is to obtain oxygen and to give out carbon dioxide. So, you have your nose, your windpipe, your lungs. So these are different parts of your respiratory system coming together to bring about a function. So similarly, the electrical system is something that is made up of different parts. Alright? So for this electrical system, the most basic one, we call it a circuit. So what exactly is an electric circuit? Let me just put in the word electric over here. Now, electric circuit is basically made up of different electrical parts. So when connected all together, the electric component should work. So let's see what are some parts that is in an electrical circuit. So firstly, you have your power source. Now, the most common form of power source that you will come across would be your battery, of course, be it rechargeable or non-rechargeable. So your battery also comes in different voltage. Alright, voltage just tells you how strong the amount of power your battery is able to supply. It also comes in different types. So you have your lithium battery that is rechargeable, that is in your phones, or you could have the conventional kind of AA batteries that you find in your remote controls. Alright, and the next thing that you have would be your wires. So your wires, usually they are made using copper. Now, just a fun fact, many of the times we see copper as one of the most common material being used as a wire in an electric component. But did you know that actually copper is not the best? Now, the best conductor that allows electric current to flow through it really quickly would be your silver and gold wires. So these silver and gold wires, because they're so expensive, they are not usually used in our everyday electrical appliances. If not, people will be stealing the wires and stripping it of the gold to melt it down or to sell it. That's one. Two, it'll be too expensive for anyone to really purchase any electrical appliance. So copper gives a good balance of the really good electrical conductivity, and at the same time at a good affordable price point for many people. So where can you find these gold wires or this silver wires? So they're used in high-end electrical appliances such as medical devices, or even your very expensive laptops and handphones. And that's why laptops and handphones can cost up to thousands of dollars, alright? Because they really need it to process very quickly. They need the electric current to flow through very easily. And then you could have a switch if you like. Now, a switch basically allows you to open or close a circuit easily. I will talk more about what is an open circuit and what is a closed circuit later on. Most importantly, you will also need an electrical component. Now, what is this electrical component that I'm talking about? Now, an electrical component in this case is basically a part that you want it to function, that has a purpose in the electric circuit. So the very common ones that you always see would be your bulb. So what other examples besides a bulb? So a bulb, when electric current flows through it in a closed circuit, it will light up, right? So besides a bulb, you also have a electric, or we call it electromagnet. So when electric currents flow through this iron bar, alright, that is coiled around with your copper wire, it becomes an electromagnet and is able to attract magnetic materials. So where can you find electromagnet in real life? That will be in scrap yards when you're trying to actually separate the metals from your other trash. Alright? And other common electrical components that you may find appearing in your practice paper and in questions could include things like fan as well. Alright? So these are just some examples. But the whole point about electric component is to actually give a purpose. Alright, what exactly do you want this electric circuit for? Alright, so light bulb to light up. Okay, so let's talk more about the different types of components that you have. Now I'm going to zoom in. Now your battery basically has two terminals. Alright, you have your positive end and you have your negative end. Now, if this is your battery, you realize that there's a little bit part that is jutting out. The part that is jutting out is called your positive end, or your positive terminal. Why is it positive? Well, you have an additional thing, so it's positive. And the other one is your negative terminal. Now, something important to remember is that your electric current always flows from your positive terminal to your negative terminal in an electric circuit, which I will elaborate more later on. So your battery is basically a source of energy, alright? Okay, now, next we have your wires. So what do your wires do? Your wires basically help to connect two terminals of the battery to other electric part so that your electric current is able to flow through the circuit. Alright? So an electric current can only flow if, let's just say, your circuit is complete, or we call it closed. So this closing part is the one that actually allows your circuit to close, okay, or complete. Switch is something that's very simple. It's basically to open or to close. It is usually made up of a conductor of electricity. Okay, so electric component. Now for electric component, I want to talk a little bit more about the bulb in specific over here, because that is something that we encounter very often. Now your bulb basically has a few parts to it. Now what is important is that you understand how it looks like inside. Now when this is the bulb, and then you have your metal case over here. Okay, so inside over here you have a metal tip. Now there is something called your filament that runs across these two wires over here. Now this one in pink, it is called your filament. Now what happens is that when electric current flows through your filament, it gets heated up and it glows, and it's this process of glowing that actually gives you the light that is actually being produced. Now another important thing is that when you connect a bulb to a circuit, you always connect one wire to the bottom and another wire at the side, because as you can see, only then will my circuit be complete. Please follow the yellow highlighter. So as you can see, when it's completed in this way, electric currents can flow through it. Okay, and I'm going to add in my battery over here to make things a little clearer. So the orange line represents my wire. So then it will flow this way. So remember, always positive to negative. Alright? So I'm going to do it one more time with the pink, starting from the positive terminal from the battery. So it will flow through across the filament and back to the negative terminal. Okay, and this is the pathway of electrical circuit. So what we have here is something that we call a closed circuit or a complete circuit. As you can see, there is no gap. Now what happens when I introduce a switch? So let's just say I decide to introduce a switch over here. Okay, now your switch, basically it can be a very simple switch, okay, that is made out of a piece of metal that is a conductor of electricity. So that you can swing. So as you can see, when I swing it this way, alright, there is a gap over here. Now because of the gap over here, my electric current is no longer able to pass across this gap. And that is where I say that the circuit is open or incomplete. So because of that, electric current is not able to flow through the circuit. Alright, and the bulb will not light up. Alright, just a very quick one over here. Now, this filament is actually very thin. Back to my filament. So if let's just say I'm going to use a very powerful battery, or I decided, I'm going to step it up and use like 10 batteries or even 5 batteries at one go. Now what happened is that the amount of energy is too much. Alright, okay, you're having too much electricity flowing through at one go. Alright, so much so that it causes your filament over here, so if we zoom in, to actually start to melt. Now when it melts, what happens is that it will sorry, let me just undo this part. So when it melts, right, there will be a gap. Okay, so when there is a gap over here, once again, your electric current can no longer flow through the whole circuit because of the gap. And we term this as the filament or the bulb has fused, or we say that the bulb has blown. So we can use these two terms to describe what has happened. So once again, let me stress, this happens when you're using a battery of a too high of voltage, or you're using too many batteries at one go. Alright, so it will cause your bulb to fuse. Okay, now next thing. So if let's just say I were to give you two instances, an application question on bulb and battery. If I were to put a bulb at the top here, and the wire is going to be connected here at the side of the battery, alright, we have to understand that in this case, the bulb will not actually light up. Why? So if you remember, one of the wire actually connects over here. However, another wire connects to the side over here at the bulb, at the case of the bulb. So because if you realize that there is actually a gap over here, because of this gap, we say that the circuit is actually incomplete and electric currents cannot flow through. So therefore, in this case, your bulb will not light up. So how do we then go about rectifying this problem? So to rectify this problem, what should have happened is that the wire should be connected to the side of the bulb, okay, at the case. So then you realize that it's a complete circuit and electric currents can flow through in this manner. Alright? And your bulb will light up. Okay? Just wanted to show you an application because this is one of the common concepts there is usually test up. Alright? Now, the next thing is that you need to understand that there is two types of circuit, which I'm going to talk about, that you need to know the definition. The first type, which I've been saying a lot of time already, is actually your open circuit. I'm going to talk more about it. Now, an open circuit basically happens when there is a gap in the circuit. So how does this gap happen? So this gap can happen when your switch is open, or when your electrical components are not connected properly. Okay, so when I say not connected properly means they are not joined properly. Okay, there is a gap. So this is also the reason why when you draw electrical circuit diagrams later on, which I will explain, you have to make sure that your lines are connected to every single part of the components. I will elaborate and I will emphasize this point later once again. So when there is a gap in the parts of the circuit, the bulb or any electric component will not work because the primary idea is that your electric current is not able to flow through the circuit. So because electric current is not able to flow through the circuit, your electric component will not work. Okay, it is as simple as that. Now, when you have I've just talked about the first type of an open circuit. Obviously, the second one I'm going to talk about is a closed circuit. So a closed circuit happens when all the electric component is actually connected together, no gaps at all, and what happens is that your electric current is able to flow through. The circuit. Now, it's important to note how I actually and what are the terms that I used. So you see, I use terms like circuit open, circuit closed, no gaps, allow electric current to flow through. Alright, the circuit. So I want you to be very familiarized with these terms and concepts that I'm talking about because they need to be included in your answers whenever you're trying to explain how the electric component is able to work or not to work. Now, the next concept I want to talk about would actually be teaching you how to use this framework that I have come up with to help you better answer questions. Okay, so let's apply what we have learned. So it's application time. Okay, so for example, if the question presents you with a circuit, alright, that looks something like this, I'm just going to draw a very simple circuit diagram. So this is a bulb, just in case you don't know. These are your batteries. I'm drawing in the switch, and then I'm closing the circuit. So what's important is you need to check if there's any gaps. Make sure there's no gaps. Alright, so the question is asking you, alright, what would happen if the switch is closed? So in this case, I have drawn the switch closed already, and the question asks you, okay, what will happen if the switch is closed? So in this case, it's closed, right? So you need to actually think about a few things. Now, I always teach my students to use this framework whenever you are answering questions pertaining to electrical system circuits. So the first thing I would use is C, okay, which stands for answer this question. Is this circuit closed or open? Next one is E. Can the electric current flow through the circuit? Last one, CEO. What is the outcome? So let's go ahead and unpack this framework for answering questions related to a circuit. Alright? So C stands for circuit, E stands for electric current, and then after that O stands for outcome. Now the first thing you want to ask yourself is the circuit open or closed? So in this example of the question, I'm going to just pen it down. What would happen to the bulb if the switch was closed? So if the switch is closed, you check, firstly, is the circuit complete or not? So in this case, I would think that it is. So to check, I would usually, take a pen or a highlighter, okay, start from the positive terminal and trace, alright, all the way to the negative terminal. So if there is no gaps, I know that electric currents can flow. So I have to pen it down in my answer. The next part that I want to talk about is when it's closed, the electric current is able to flow through, right? That's my second point. So I need to write that down. Now the third point is talking about the outcome. Now the outcome depends on what is the question about, or maybe even what is the electrical component. So basically, right, in this case, they're talking about a light bulb. So the outcome is when electric current flows through, the light bulb will light up. So let's go ahead and see how does your answer look like. So the first thing I'm going to talk about is actually close or open, right? So when the switch is closed, the circuit is complete. Or I can use another word also known as closed. Thus, electric currents can flow through the circuit. So this is the second point on E. And the last one on outcome, causing the light bulb to light up. Okay, so this is the outcome. So this is the first part is talking about C, second part is talking about E, and the last part is about outcome. Alright, so using this framework, you can interchange it with many application questions. So maybe another question, instead of having a light bulb, you have a electromagnet. So in this case, your outcome, you just have to change it to, when the switch is closed, electric current can flow through the circuit, causing the iron rod to become an electromagnet and attracting paper clips, perhaps if the question has paper clips in it. Alright, so this CEO strategy is really, really good for answering this type of circuit questions. I hope I'm clear about it. Alright, so moving on, the next part, I would like to talk about electrical conductors. This is a very simple concept, nothing very difficult. So basically, you need to understand that electrical conductors basically allow electric currents to flow through. Okay, so what are some common electrical conductors? You have your metals. This is actually very, very common. So things like your copper, gold, and silver. So copper is used in wires, like what I have explained. Okay. So then the next part, you have your electrical insulators. So electrical insulators is basically the opposite of electrical conductors. They do not allow electric currents to flow through. Alright, that's about it. So what are some examples? It will include your rubber and plastics. So these two are your very, very common electrical insulators. So why is it important to know these two different things, electrical conductors and electrical insulators? Now, they will usually come out as a form of application questions, like how? So for example, you have a circuit, and then after that, within that circuit, they tell you that there is a material that's being changed. So for example, I'm just going to draw you a very simple circuit over here with your electrical source, your batteries, and then after that, they tell you that there is this one component here that is made of different materials. So your materials can be X, Y, Z, something like that. And then they tell you, oh, when you put in X, light bulb lights up. If you put in Y, okay, your light bulb does not light up. And then they ask for a conclusion. What can you say about material X and Y, okay, or X and Z? So based on the fact that if, let's just say, when you put in material X and the bulb lights up, this means that your electricity is able to flow, right? Okay, and you remember the definition, it says that electric conductors allow your electric currents to flow through. So you know that that material is actually an electrical conductor. So you can say that, for example, if X is here, you can say that, oh, material X is a conductor of electricity because it allows electric current to flow through, causing the light bulb to light up. Alright? The opposite is also true. If, let's just say, material Y is an insulator, and you decide to when you change to Y, okay, your light bulb does not light up. So why does it not light up? Because there is a gap. Okay, there is a gap because your insulators, if it's Y is an insulator, it will not allow any electric currents to flow through. Okay, so because of the gap, we say that the circuit is no longer complete. So you see how this is all coming together. I'm using terms like circuit not complete, does not allow electric currents to flow through. So it's very important to get the first part right, and that's how you can gel everything together. We're adding on new knowledge, but at the same time, we are also using terminologies and knowledge from the previous part of this revision to help us formulate our answers and conceptualize our thoughts. Okay? So your insulators, they are great for applications for what? On wires, wrapping wires. They can be found on plugs. Okay, and basically what happens is they prevent us from getting electric shock, right? Okay, it prevents us from getting electric shock. Okay, so these are some application questions on electric conductors and electric insulators. Now, the next portion I'm going to talk about is a whole new portion, and this portion I'm going to talk about your circuit diagrams. Now, the first part is we have to understand what exactly is a circuit diagram. Now, we have seen, okay, so something that's not a circuit diagram will look something like this. You have your battery, okay, you've got your wires, squiggly wires, okay, in real life they look very squiggly. You've got your bulb that looks something like this. I'm going to try my best to draw this. Not very good at my art, my apologies. Okay, remember, one must be at the side and one at the bottom, and then so it's something that is real life. This is not, I repeat, not a circuit diagram. Okay, this is like a real life drawing, okay, or a pictorial representation. Now, in science, we always want things to be simplified, okay, because not all scientists are good artists, right? And the whole point about a circuit diagram is to help people understand very easily and simply how the components are connected. Alright, is to help them see, is it a series arrangement? Is it a parallel arrangement? Because if you were to use this type of pictorial drawing, it can look very messy because the wires are everywhere. So in circuit diagrams, they are very simplified. They use symbols to represent bulbs. So your bulbs can be heart shaped, it can be square shaped. You know, to me it doesn't matter, because the symbol I'm going to use is just going to be a circle and a cross and a center. That's it. And your wires, it could be curly whirly, but in a circuit diagram it's always straight lines. Okay, so I'm going to illustrate to you very simply how does a circuit diagram look like. What's an example? So I'm going to transform this pictorial form into a circuit diagram. So let's take a look. Now, in this circuit diagram, okay, before I even do that, I want to just add in one more component over here, which is a switch. Okay, let's just say you have a switch, something like this, okay? Okay, I'm not very good at drawing, but that's a switch. Alright, so this is your battery, your switch, and your bulb. And of course, this is your wire. Now, so a circuit diagram, first things first, you must always use a pencil to draw, okay? Use pencil. Now, rule number 2, use ruler. Rule number 3, make sure there is no gap. And rule number 4, you always draw the exact number of components. So you make sure that the number of components is accurate. Alright, so for example, I'm going to translate this pictorial one into a circuit diagram. If there's only one battery, I'm going to draw one battery. If there's two batteries, I'm going to draw two batteries. There's no way I'm going to draw 10 batteries. And you follow the orientation of the positive and the negative terminal. That's important as well. Okay, so first things first, use a ruler. Okay, now this over here, I'm going to zoom in, is the symbol for a battery. Two vertical lines. Now, the longer vertical line represents the positive end, and the shorter one represents the negative terminal of your battery. So if you take a look at the pictorial part of it, my positive end is actually on the right hand side. So that's what I'm going to do here. And then after that, I have a wire coming out of my battery from the positive side. Okay, so I'm just going to draw a straight line like this. Sorry. Okay. Then after that, there is like a bend. I'm going to go down straight, once again making sure everything is connected. And then the next electrical component would be my bulb. So the symbol for bulb is just a circle with a cross in the center. That's it. And then it continues. Alright. And then there is another bend here. I have a switch. Now a switch is very simple. It's just two small circles. Now you have to check whether or not in the diagram the switch is closed or open. So in this case, mine is open. So I'm going to draw it open like this. Okay. And then after that, continue the wire. And then there's another bend. Okay, and then I close it up. So this is actually a circuit diagram. Now a few things to note. There are no gaps at all. So even if you zoom all the way in, right, there is no gap. And, sorry, just to be sure, okay, the wires needs to be in the center of the battery symbol, okay, which was not what's happening just now. So I had to correct it. So make sure there's no gap in your components at all. That's very important. Count the number of components. So if there's two bulbs, make sure there's two bulbs. If there's one bulb, draw one bulb, just not draw extra. Similarly for your batteries. Now, if there is more than one battery, okay, you always arrange it positive, negative, positive, negative, positive, negative. What do I mean by that? So I'm going to show you. So if there are two batteries, I'm going to erase this example. You want to make sure that your circuit looks like this. So your positive terminal is always next to a negative. And a negative is always next to a positive, because in real life, that is how your batteries are being arranged. Okay, so make sure you get that right. If you get the orientation wrong, marks will be deducted. If there's gaps in it, marks will be deducted. Now the next thing is also you need to be careful of whether or not this is going to be a parallel or a circuit arrangement. So in this example that I've given you, it is called a series arrangement. Very simple. Okay, but in another example, if they give you a parallel arrangement, you're going to have to draw it, which I will exemplify later on. Okay, so I just want to illustrate that. Now, if you're tasked to draw a closed circuit, it's just two circles and then join in the line like that. That's it. That's a closed circuit. It's very simple. Alright, so the next part I want to talk about is basically variables affecting electric current. So let's do a very quick recap. Alright, so we know that your electric current is basically like your energy. Alright, so in order to do work, you need energy. So the amount of electric current affects the work done in an electric circuit. So what do I mean by that? So work done in this case could be how bright your bulb might be. So if your electric component is a bulb, would be brightness of bulb. That is actually the most common and the simplest example I have for you. So there are a few factors, or in very scientific term, they like to use the word variables, that can affect electric current. Right, so they can affect it in the form of the amount of electric current you're flowing through, alright, or the ease of it flowing through. So what are some of these variables? let's take a look at it. Okay, so we have firstly number of batteries that is arranged in a series circuit. So you know I keep talking about series and parallel, so perhaps I would just want to introduce to you very quickly what is a series arrangement. Now, so a series arrangement means that there is only one pathway that can be taken in an electric circuit, in short. So this is just a very brief intro. I will talk more about it later. So let me just very quickly draw you a series circuit. So something that's like this. So this is a series circuit, whereas for your parallel, it looks like this. Same number of batteries, however, your bulbs looks like this. So what I like to tell students is, if there is only one pathway, think of wires are like roads or pathways for your electric currents to flow or to travel. If there's only one way in the first case, this is actually series. So I like to think of series. S stands for single pathway. Alright, and parallel on the other hand is not. Okay, so parallel, if you take a look at it, there is actually two pathways. So I can travel from here to here. That's the first pathway. I can also travel this way. Alright, so there's actually two pathways in this case, and we say that this is a parallel circuit. Alright, so now that you've got a quick intro, I can then jump into the variables affecting your electric current. Now, let's talk about the number of batteries, number one. I'm talking about variables affecting electric current. Okay, so we can adjust the brightness. Remember work done in electric circuit, I talked about, for example, if you want the bulb to be brighter or dimmer, that's a kind of work done when it comes to electric systems. So the first thing you can do is to talk about the number of batteries. So the more, the brighter. The bulb would be when lit up. Okay, that's the first thing. However, alright, you need to take note that you cannot use too many. If not, there will be too much electric current flowing through the filament, causing it to melt. So the more also means that there is more electric current flowing through, which results in a brighter bulb. That's the first thing. Now, take note that if there is too many, the electric current may cause the filament to melt, and this results in your bulb fusing. Alright, we talked about this earlier. Alright, so when this happens, it introduces a gap in the circuit, and we say that the circuit is incomplete. Because of that, electric current can no longer flow. What's the outcome? The bulb will not light up. Okay, just take note of that. Now, the next thing, So with more batteries in a series circuit, the bulb becomes more bright. However, if you add more bulb, the second variable, when you have more bulbs in a series arrangement, okay, it actually becomes dimmer. Now this is not true for parallel, which I will explain to you later. So when you have more bulbs in a series, let's just say you add like 3 bulbs, alright, it becomes less dim. So if I'm going to compare two circuit A and circuit B, now the number of light rays that I'm going to draw gives you a rough idea of how bright it is. So if this is 5 rays, okay, of brightness, this is probably only 2 for each bulb. Now why is this the case? So remember I told you to think about your wires like pathway for your electric current to flow. So in a series arrangement, there is only one way. Remember S for singular. Okay, there's only a single pathway. So all your light bulbs, you can think of it like traffic lights. Okay, so every time it passes through a traffic light, there'll be a brief stop. Okay, so because of that, the flow of it is actually slower or less in that sense. Okay, I mean this is not totally accurate, but it's to help you remember. So in circuit B, there is only one traffic light, so therefore electric current can flow faster. Okay, whereas in A, because there's only one way, it has to go to 3 light bulbs, 3 traffic lights. Alright, and because of that, the flow of current is actually a lot more diminished, slowed down by a lot. Okay, so there is less current flowing through each bulb, and that is the reason why. Okay, so a proper explanation for this, if you were to pen it down, would be as more bulbs are added to a circuit, or rather a series circuit, less electric current flows through each bulb. Thus, the brightness of each bulb decreases. Okay? And that's why. Now, however, now we are going to a new area. What if you add more bulbs in a parallel arrangement? Now, that is a totally different ball game altogether. Now, when you add more bulbs in a parallel arrangement, the brightness does not change at all. It remains the same. Okay? So I'm going to pen it down right now. So when more bulb is added to or in a series arrangement, I think it's better to term it that way, in a parallel arrangement, the brightness of each bulb remains the same. And this is a key idea. Now I'm going to draw you 2 circuits, in fact 3 circuits for you to see. Now you need to first understand what will happen if you have one bulb only. So a lot of students cannot see that when there is only one bulb, the brightness is the same as having two bulbs. So for example, if I only have one bulb, okay, it is 5 rays of light worth of brightness. 1, 2, 3, 4, 5. Now, you need to first understand that a parallel arrangement starts off with a series arrangement. What do I mean by that? So take a look at, this is A, and take a look at B now. So let's just say I'm going to add one more bulb. Now, before I add that one bulb, I'm going to just have one bulb. So I would say that circuit A and circuit B is exactly the same. So the amount of brightness, given the voltage and number of batteries, everything else is the same, is going to be 5 rays of light as well. But wait, I'm going to add one more light bulb arranged in a parallel. Why parallel? Because if you look at bulb 1 and bulb 2, bulb 1 is parallel to bulb 2. According to what I told you earlier, the brightness must be the same. So once again, it should be worth 5 rays of brightness. Now, if I'm going to do a third one, C, same thing. I always start off with a series, in fact, and then I add on another bulb that is parallel to the first one and then the third one. So because when it was a series arrangement, there is 5 rays, the second one should be 5 rays, so should the last one, also 5 rays. Now, take note of this, alright, because there is alternative pathways. Alright, when you take a look at it, okay, I have one pathway here, two pathway here, okay, and one more pathway here. Okay, this is a parallel. And here's the wonderful thing about it. If any one of this bulb fails, there is no effect to the remaining two. So let's go ahead and undo this. So for example, let's just say bulb number 1. I'm going to zoom in, 2, 3. Bulb number 1 fuses. So when it fuses, okay, we say that there is a gap in the circuit, correct? So there's a gap here. Let's go right ahead and erase that. Now, initially, there is a pathway that's going on here. Now, because of the gap that's introduced here, we know that this is no longer possible. Alright? However, for the rest of the circuit, we know that there are alternative ways, okay, to reach the other two light bulbs. This is the first way and this is the second way. So as you can see, bulb 2 and bulb 3 are not affected at all. Their brightness will not increase, neither will it decrease because of the fusing of one bulb. They will remain the same. That is the key idea. So be very careful. So in short, this bulb over here is the same brightness as this bulb, this bulb, this bulb, this bulb, given that if the batteries are all the same. Alright? So this is the key idea to take away from bulbs arranged in a parallel arrangement. Now, when would you use this? So you will use this parallel arrangement in a home or in Christmas lights, whereby with one bulb fuses, not the entire home will go out of lights. Okay, so this is something that you need to understand. Okay? So you also need to know about some ways to make use of electricity wisely, and that's because electricity is a very precious source. Why? Now perhaps a lot of you don't understand how electricity is being produced. Now in order to generate electricity, you basically need to turn a turbine. Okay, So basically, how do you generate electricity? Let me just briefly walk you through so that you have a better understanding. Now, this is not the complete story, but generally, the first step is, the general step is that you need to turn a turbine, okay? Now, what is a turbine? A turbine is basically this thing that turns, and as it turns, it will actually generate electricity. So the question is always, how do you then turn a turbine? So basically, the most common way is to actually use steam, because steam is so-called, like, you know, it rises, there's pressure in it, all right? It causes the turbine to spin. Now, then the next question is, how do you then produce steam? You need to boil water, right? And then the next question is, how do you boil water? You need a heat source, right? And it is this heat source that is a problem to all of us. What most people do is they use fossil fuels. So these fossil fuels, right, when you burn it, okay, it gives you that heat. It produces that heat that is used to boil the water. Now, fossil fuel causes air pollution, and it's something that is very limited. Alright, limited meaning that we will not see it being renewed during our lifetime. So an average human lifespan now is about 80, but fossil fuel takes millions of years to form. So a non-renewable resource, alright, is basically a resource that cannot be seen again or regenerated within a person's lifespan. So once again, fossil fuels, millions of years, human lifespan, 80 years. Not happening, not possible. So we're going to deplete it, which is actually the main problem now. It's a limited resource. So that's why, you know, scientists, they're using hydro electricity, they're using solar panels, etc., and cleaner forms of energy to try and solve this problem. And also, it's pretty costly. Alright, so you have to buy the fossil fuels, you have to burn it, so all this costs money. Okay, so this is the reason why we need to conserve electricity. So basically, we need to make sure that we're using it wisely and not wasting it. Okay, so when you are not using electricity, please switch off appliances when not in use. Okay, and of course, don't switch it on to the maximum power or the lowest temperature for your air conditioner if it's not needed. Alright, so that's one way we can conserve electricity. Now, how to use electricity safely is the last part I want to talk about. So safe usage of electricity. Now, 1, do not touch of power sockets with wet hands. Why? Because water is a good conductor of electricity. So if you're going to touch a socket, well, the electricity is going to love to pass through that water that's on your hand, and then ultimately the electric current will pass through you, and that's where you get an electrical shock. Okay, so make sure that you don't do that. So also, don't overload electric sockets. So please do not plug too many appliances into one socket. Alright, we all know how people like to use the multi-plugs and then they start stacking on top of each other. So what will happen is that it could cause a fire. Alright, if too much current gets passed through that one socket point. Okay, you don't want to do that. Alright, so in conclusion, what are the few things we covered? We've covered about what is an electrical system, what are the different components of an electrical system. We also talked about how to answer questions pertaining to your electric circuits using the CEO framework, which I talked about. C being whether or not your circuit is closed or open, E, can the electric current flow through your circuit, and O, what is the outcome depending on what type of electric component you're given. We also talk about your circuit diagrams, how to draw it, make sure that there's no gaps, make sure that you're drawing the right number of components. Alright, your switch is open or closed. Follow the instructions given to you. We also talked about what are some of the variables that could affect the brightness of a bulb. So we've talked about number of batteries. So when there is more batteries arranged in a series circuit, your bulb become brighter. Alright. We also talk about the number of bulbs in a series circuit versus the number of bulbs in a parallel settings. So it's important to remember that in a parallel setting, as you can add as many bulbs as you want that's parallel to each other, they all have the same brightness. It's just that your battery will get drained out really quickly as compared to adding more bulbs to a series circuit. It becomes dimmer with every additional bulb. Alright, so it's important to be able to identify a series versus a parallel bulb. Alright, sorry, a parallel circuit. So with that, thank you very much.